הרבה אנשים פונים אליי ואומרים, תקשיב, אני מנסה לעבוד עם הצ'אט GPT, אני מבקש ממנו משהו, שואל אותו שאלות, אבל הוא לא נותן לי את מה שאני רוצה. אתה יודע, אני לא כל כך מתלהב מכל הנושא הזה של הצ'אט GPT. מגניב, אבל בדרך כלל הבעיה היא אצלנו, לא אצל הצ'אט GPT. אם אי פעם שיחקתם עם הדברים האלה, אז אתם יודעים שהשאלות שאנחנו שואלים את המודלים האלה נקראים פרומפט. והבעיה של רובנו שאנחנו לא יודעים לכתוב את הפרומפטים הנכונים, אנחנו לא יודעים לשאול את המערכות האלה, את השאלות בצורה שתביא לנו את התשובה שאנחנו רוצים. זאת בדיוק הסיבה שעשיתי את הקורס שלי, בינה מלאכותית, שבה אני מסביר בדיוק על הנושא הזה. איך ניתן לכתוב את השאלות לצ'אט GPT בצורה שנקבל את התשובות שאנחנו רוצים, בצורה יעילה ומהירה. אבל אם אתם רוצים לדעת איך עושים את זה מהמומחה הכי גדול בעולם, קוראים לו פרופסור ג'ולס ווייט, מאוניברסיטת ונדרבילט שבטנסי. והבן אדם הזה מקדיש את כל החיים שלו בשנתיים האחרונות כדי להבין בדיוק איך לדבר עם המודלים האלה ואיך לשפר את הביצועים שאנחנו מקבלים מהם. זאת הייתה שיחה מרתקת שהוא נתן כל מיני טיפים ממש ממש טובים לגבי איך לדבר עם המודלים האלה, ובין היתר גם דיברנו על העתיד של מדעי המחשב, כאשר בינה מלאכותית יכולה לכתוב המון קוד. אז בשביל מה צריך בדיוק ללמד מדעי המחשב אם אפשר לתת את זה לבינה מלאכותית? שווה מאוד. השיחה היא באנגלית, אני יודע, אז תפעילו כתוביות. אני יודע שאתם לא מפעילים כתוביות, כי יוטיוב אומר לי, ושווה מאוד להפעיל כתוביות כדי ליהנות מכל העושר הרוחני שיש לפרופסור ג'ולס ווייט להציע. פרופסור ג'ולס ווייט, how are you? Thank you so much for coming today.
Yeah, thank you for having me. I look forward to the discussion.
Yes, it's my pleasure, and finally I have a guest with a perfect audio and a perfect video, so it's going to be also perfect for the viewers. I want to start with something that you said in a recent lecture about generative AI, and you mentioned that if someone had told you about ChatGPT capabilities before its release, you wouldn't have believed it's possible in your lifetime. My question is, or my first question is, if you may, can you elaborate on like the most surprising aspect of Gen AI that you have encountered in the last 1 year, approximately?
Yeah, well, I think the most, I can say the first thing that got me to really pay attention was I had a moment, my father's in his 80s and we were on the phone. And I was telling him this thing called ChatGPT is absolutely incredible. And so we were interactively, like he would say, oh, ask it this or tell it to do that. And so we were talking on the phone and we said, okay, let's imagine a world without odd numbers. What would have to change in our world if we didn't have odd numbers? And it gave this incredibly like detailed, thoughtful answer on all these aspects of the world that would have to change without the concept of odd numbers. And like, to me, that was the first point where I really paid attention. I said, wait a minute, this is something different than, you know, anything we've had before. And I think that it's taken me time to evolve my thinking of what it is. But I think the part of it that really surprises me is the part that everybody complains about. So everybody's talking about hallucination as if it's a bad thing, but I think it's the foundation of all the creativity, and the creativity allows it to answer the odd numbers question, but it also allows it to do things like, the other part that I think is most surprising to me is the multimodal aspect where you can take pictures of things and give it other inputs. And I think it gave me new appreciation for how important this is. And so a simple example I gave in a recent talk was I took a picture of some sushi in my fridge, and it's like some leftover sushi. And I'm like, now give me instructions how to make this. Right. I'm pretty confident that before ChatGPT, if we had like teams of PhDs and all the supercomputing we wanted, and we'd said, now create a system where you can take a picture of any arbitrary thing in the world and it can tell you how to make it, even if it's not perfect, if it's approximate. And I don't think we could have gotten close. And now it's easy to create that system. So I think it's surprising to me just the flexibility and creativity, and that it works and sort of computes in a totally different way than things we had in the past.
You know, I couldn't agree more about the idea of hallucination, and Jeff Hinton said exactly this very thing, you know, that he said, we as humans, we also hallucinate. We don't remember like a videotape, okay? And the process or the mechanism of ChatGPT is very similar to the process of how humans understand the idea of embedding and take it to another dimension where we have like a semantic or where different similar meaning things can be combined together, which leads me, I think, to another question. We have like this Yann LeCun, Jeff Hinton debate whether those giant LLMs can really understand or not. And we have this Jeff Hinton school that said yes, basically yes. And we have the Yann LeCun said no, we need embodiment and we need something else. And my question is, where do you stand in this Yann LeCun, Jeff Hinton debate, or, and I will give you for the first time another option, that this debate is irrelevant when you want, just to take and utilize those great machines for your benefits.
So I think the debate's important, but I don't stand on either side because I'm on the third side, which is like, I don't care if it understands or not, because now I have a way to compute an answer that takes into account those things. So if I can say, I do an example in my class where I say, create a meal plan that combines flavors from Uzbekistan and Ethiopia, but has ingredients that I can get in an average US grocery store. And it, appears to have an understanding of the concept of an average US grocery store. And I don't care if it, practically speaking, if it truly understood it or not. But from a computer science perspective or a software engineering perspective, I now have a computational tool that can compute an answer that appears to reason in the same way that a human does. And whether or not it's actually understanding or not isn't, I don't think, important for, and there maybe we'll find some examples where it is important, but I think generally speaking, it has the capability to compute with it. And if I have now a computational building block that I can use, even if it's imperfect, even if it's not built on true understanding, but it allows me to do things that are new and fundamentally exciting. I think that's really important. It's the same thing with creativity. Is it really creative in the way a human is? I don't know, but having somebody made the statement to me, it makes creativity so cheap that it's cost effective now. Right, that's a building block.
Definitely, I'm going to take it. Yes, yes, I'm going to take it. I think I want to raise two things. One, the idea is, and I give many lectures about AI for the real world. For companies across Israel, and the same questions that I get over and over again: can I use ChatGPT for my problem? And I always give the same answer. If your problem can benefit from advice from a smart person, you can utilize ChatGPT because it will give you the same kind of advices that you would have get from a smart person. And I think that this is a very important thing to remember. But when you said I have a computation tool, the idea is, the question whether it really understand has a ramification, or how much you need to go over the computation process in order to make sure how much can you rely on the output. And if you say, I'm not in the mission critical assignments, okay. But if you are in the mission critical assignments, so maybe this semi reasoning can be vital.
Yep. Well, I agree. I think that, my intuition and gut is that we will get it to where we can use it in many, many mission critical places. I think part of the way that we get there, though, is by rethinking the problem, so that we're trying to go and put it into the existing system, the existing way of doing things, where it may not be the right solution. But the example I always give is the Vanderbilt Medical Center. They have an app called My Health at Vanderbilt, where you can go in and find all kinds of information about your medical record. And we could go and add a text box there where you could type in, what was my blood pressure at my last visit? But realistically, we're not going to do that because there's a huge risk that if it hallucinates and gets it wrong, it could lead to some tremendously adverse outcome. But we could simply take the problem and rephrase it as that what the goal is to get the human the information they need. But the model doesn't have to generate it directly. It could say, which screen in this app is likely to have this information? They type in, what was my blood pressure at the last visit? And it navigates them to the screen. And so rethinking, what is the problem that we're really trying to solve? Maybe taking a step back and then thinking about where's the right place for the LLM to play in that problem. And so you mentioned like asking a really smart person. And I think the key is that like probably a really smart person can help you at different stages in the problem. Maybe they're an expert on the exact problem topic itself, or maybe they're an expert on like helping you think of different analytical frameworks or ways of breaking problems down, but they don't have actual specific expertise in that. Or maybe they're a motivational coach that makes you feel excited and more inspired. And I think that's the thing that's so tricky, is that it's maybe the LLM will directly have knowledge and expertise on the problem that you're working at, or maybe it comes into play in some other angle. And those other angles are things that computing just couldn't do. You know, you couldn't say like, inspire me, give me crazy ideas, right? That's something we didn't have. So maybe the LLM can help in that just inspiration piece. And that's the hard part, is because there's such an infinite sort of surface of areas that you could go and plug it in, you know, that's where it gets really tricky. So I think it can have impact probably on almost every problem, but the hard part is trying to figure out, where do I plug it in on that problem? Or maybe the thing is thinking about whether or not I should be solving this problem at all and solving a different one, because the LLM helps me figure that out. And I think that's where it gets really tricky.
And it's not just where, it's also the how. And this, I think, leads us to the idea of prompt engineering. But before we go into prompt engineering, you're a professor at the computer science department at your university. And I'm also a faculty member at the computer science department at my university. And we are facing a big issue right now regarding, you know, we in Israel facing another big issues, but this is another question. But the idea is, do we need, or how do we as an institution that try to educate the next generation of programmers and computer scientists, how do we incorporate the idea of ChatGPT, Claude, in an efficient, smart way? Now, we had before Wolfram Alpha, but it wasn't the same thing at all. So my question to you is two. One, what is your opinion? And two, if your opinion is different than your university opinion, what is your university opinion?
Well, the way that I kind of position it is, in my graduate class last week, when I teach a class on software engineering in the age of AI. And I mean, we're going to talk about prompt engineering and agents and all kinds of things. And the first day, what I did is I did a poll of the class, and I said, basically, in 3 years, 5 years, and 10 years, you know, do you believe in 3 years that at least 5% of all source code will be manually written by a human being?
At least 5%. At least 5% will be manually written. Okay.
Manually written. Like, do you believe that at least in 3 years we will still have at least 5% of source code? In 5 years, do you think we'll have at least 5% of source code? In 10 years, do you think we'll have at least 5% of source code? And I think there's around 40 graduate students in my class, and there was near 99% agreement that within 10 years, we would not have 5% of source code written by human beings anymore. And so, I mean, that's crazy, right? That's my entire lifetime has been.
Just a second. What's your opinion in this poll? What did you answer?
I think 10 years is a reasonable. I mean, I think within 10 years, I'm guessing that we will probably not have 5% of code written by human beings. I mean, if you look at the, so there was GitHub talked about, for people with Copilot, actively using Copilot, that 40%, I think what they said, and now I'm going to maybe get the statistic wrong, but I think roughly what they said is, of the people using Copilot, 40% of the code that they produced was 100% AI written with no modifications. And those are the current adopters of it. So,
which are the early adopters, which are, I think, the most advanced programmers in the world right now, basically, because the majority doesn't use, use Copilot. Okay.
So I think that I think that within 10 years, less than 5% of code will be written by human beings. But I also think it could be faster than that. I don't know. So that as an educator, what I feel like is like, well, if we know within 10 years, we don't think it's going to be useful, we really have to figure out what we need to teach and how. And so on the one side, I feel like as a computer scientist, we've always been telling students, no, you need to pay attention to algorithms and data structures and architecture and all these concepts that are really important to understand. And they've always said, no, I want to learn to program. I want to know code. I want to do these things. And I've always been telling them, look, and I would always show them, like, here are the languages I learned and frameworks and things were exciting that people loved and everybody wanted to learn when I was like in an undergraduate learning computer science. And here they are today, and none of them overlap. And therefore, you should just know that, like, what's the only thing that that's gonna matter is all of these principles and concepts and things I'm teaching you. And they would always say, yeah, and then ignore me. And now I can just say, look, I promise you, like, if 10 years from now, we all agree that there's going to be, humans aren't going to be writing the bulk of the code, well, then all these principles and concepts in this class are going to matter. And I think that what we're seeing now is that that's really come to pass, but now we're sort of trying to figure out, what does that mean? Like, how do we teach those principles and concepts? Well, algorithms, we've been doing it for a long time. We've actually been teaching probably a lot of these things. And I think the struggle is that until we've seen it happen, do we go ahead and change now and say, well, we're going to take, like if I change and I say, well, I'm not going to teach my students to code anymore. Well, next year, that probably hurts them in the job market, And 3 years out, it's probably still hurting them in the job market. 10 years, maybe it doesn't make a difference. But we're not, our students who are juniors and seniors, like, could we really, like, not teach them to code and just say, well, we're dropping that because ChatGPT will do it for you anyways? I don't know. So I think that probably we're going to have to figure out some sort of hybrid process, and there's going to be, it's going to be a little bit of bumpy road while we figure it out. But I can say from a software engineering perspective, from day one in, spring of 23, I was telling all my students in my software engineering class, you need to use this for every single thing that you're doing. And I was telling them to use it in ways that they weren't necessarily thinking of. Like, they struggle in sort of conceptualizing, like, what are all the architectures and tools and things that I could use to do this? They just dive down into some very nitty-gritty detail. And I say, no, take a step back and use this to help you explore what might be options about how you could structure the architecture of your application, and now have it simulate it without actually writing any code. Just tell it to pretend to be that API, and it can do it really effectively. And then, like, okay, now you've got this concept, have it kind of like simulate, generating what user requirements might look like for that system, and generate many different perspectives of user requirements from different subject matter experts. So I think that even if we don't want to focus on the code piece, and taking away that from students, I think we need to teach them all these other ways that they can use it that bring them closer to the concepts and force them to think about the concepts more. And then over time, I think that, yes, we can get it to generate code, but there's so many other things that we can do around it. And I think we should be teaching those now for sure. And teaching students ways of using the tools that help them to think through problems more, engage them more. And then the code piece we can figure out over time.
Okay, so I must ask you right now, because I had a very interesting conversation with one of my students, and she said, "Listen, I can't solve your homework, and I can use ChatGPT, but it will be cheating." And I told her, "No, you can use ChatGPT in another way, which will not be cheating. You can ask ChatGPT, okay, give me a hint, give me a road, give me a plan to how do I tackle, or how do I address this question?" But what you said just, leads me to the next question, because if ChatGPT can actually do all the programming it also can do most of the algorithms because it has all the Corman algorithms that we know that we worship in computer science built in not in pseudocode, but in C#, in C, in Python, in Java, in everything. So why do we need to, why do you mark the stopping point at we need to learn concept and algorithm, where concept and algorithm can be learned quite efficiently if you go over all the code in the world in GitHub?
Yeah, well, I think this is a great question. So I think that, I don't know if I know where the boundaries are, but I would say that my experience, and we'll see how these models evolve, my experience and where we are is that one of the really important roles, like I look at software engineering, like one of the problems we've always had is people don't really know how to express the problem, express the requirements, coordinate, get all these different parts of the system, anticipate all these different unexpected ramifications of decisions across different parts of the system. And I haven't seen generative AI, and I think it's going to be, since we think of it like a human, I think it's going to suffer from the same problems that we do, which is that, we go and build these big systems and suddenly we're going to have issues where, the problem is broken down wrong, or there's unexpected, side effects that impact other parts of the system, all of those types of things. And I don't think it's just going to solve it for us, but I think that's why it's really important is like the human being is going to be solving these same types of issues of like, how do I think through all these complexities and balance this in my head, but then work with the LLM to help overcome them. Because I think what's going to happen is it's like we're in computer science, we're always driving the level of abstraction up, but in building more and more complex systems. And we're going to have to, this is going to be a tool to build that, next level of complexity in systems. And what we're going to do is we're going to end up with an explosion in complexity, but we're going to have human beings now, rather than a compiler that's, does some optimizations and things, or rather than some framework that's doing it. Now we have sort of like almost like an active intellectual partner that we're working with to try to solve these problems. So I don't think it's just going to solve it for us. I think we're going to build bigger and harder to reason about systems, harder to maintain systems. And I don't see LLMs or agents being able to just suddenly coordinate and do all these things, because humans also can't do it, at scale. So I don't think LLMs are going to suddenly get it.
And maybe the answer is something that we just don't want to hear. And I think that the answer is, there is a correlation between good programmers and programmers who know many functions by heart. Okay? You don't need to memorize function, but there is a good correlation. If you are a good programmer or a great programmer, you probably know many functions by heart. And this is basically, the idea of the working memory. If you need, to think about, just a second, how do I write you need your working memory to be free in order for you to think. And this is maybe the problem, because a good programmer will benefit much more from Copilot than a mediocre or bad programmer. But in order to be a good programmer, we need to teach them how to program. So there is a vicious circle that you cannot escape.
I totally agree. But maybe it's that it's not necessarily that we need to, well, I've started to think about it differently. It's not necessarily, I'm trying to stop using the term programming, because I think at the moment we start using the term programming, we start thinking about source code, because that is the only way to program. Mm-hmm. And I think what we've discovered is there's many ways to program. But I agree 100% that what we want is students that know how to I think of programming as like controlling computation, going and solving, configuring computer systems and resources to solve problems with computation, and configuring those computations, or whatever we want to call it. And before we expressed that in code, now we don't necessarily need to. And so when we think of it that way, really the goal is to teach people these sort of concepts, all these building blocks in computing that they're going to be assembling. But I think the other thing is that I think that when I think of computing, what's happening with LLMs, I think there's kind of two things. One is that these LLMs have completely new computing capabilities, like take a picture of something and tell me how to make it, right? That now becomes a building block. It's a very high level of abstraction. It's a reusable function. How do I make it? I can apply it to a PowerPoint. I can apply it to an idea. So we're going to have to rethink, how do we architect computations around those building blocks that also have very different properties in terms of like how accurate and repeatable and reliable they are. And then I think the other piece is that we're going to be building interfaces where the interface isn't just, a GUI or something very static and fixed. It's going to be, we're going to create these environments. I think of it kind of like a computing canvas where there's going to be all these APIs. And the goal really is to move much of the problem solving closer to the end user, so that at the moment that person in that office is like, I need to be able to do this, they describe what they're trying to do to the LLM, and then it sort of assembles the computation for them to do that. And so I think trying to figure out the architectures that work like this is going to be really, really interesting and a ton of challenge. And that's where computer scientists are going to have to play a big role. But I think the other piece that's kind of interesting is that, especially with agents that can go and use tools like the GPTs that can go and use tools, is there's sort of new forms, I think, almost of computation. One was we can have the agent generate code, which then becomes a repeatable known quantity like we have today in computer science. And it can just execute it over and over. It generates it once, either at this point that we're doing software engineering or with a tool like, ChatGPT Advanced Data Analysis, where it generates the code. You don't even see it. It runs it, it checks it, and it just gives you the result. So it's sort of dynamic. But we can also have things where you have like really a prompt is essentially code now. And so for certain types of computations, you're going to be able to just do it in a prompt. And then I think the third thing is that agents don't have to generate code at all, because they can react, right? So I can have, the agent can go and say, oh, I'm going to check that spreadsheet and see if that expense already is there. And then it gets it back and it says, oh, the expense is already there. Therefore, I'm not going to enter it in because it's already been entered. And before that would have required a whole bunch of conditional logic that's put in the source code. But now that's just a sequence of prompts. And there is no fixed sort of pathways. There's just sort of a guiding set of instructions. And so I think these styles of computation and architectures are so radically different from what we've had. If nothing else, there is a vast space for computer scientists and computer scientists, students to figure that out and what that's going to be.
Basically, what you're saying, that the syllabus or the learning plan in your university, the computer science department in 10 years will be vastly different, but we still don't know how, because we have like this bridging time or bridging gap that we still need to teach the old way. And to be perfectly honest, we still don't know how to move to the less than 5% of the code will be produced manually.
Yeah, I think that's it exactly. And I would say that I think the hard part is like, we also don't know where the growth is going to be. So I think about like when we're preparing our students for the future, we also are always thinking about where are the areas of growth that we want to equip them so they can be part of that growth. And it's really hard to foresee the areas that are going to really radically grow because of all this stuff. And I think that's also the hard part, is like we're trying to project out in the future and say, where do we want to position our students to be successful at such a point of rapid change? And so it's a tough place.
With your permission, I would like to add another problem. The school plan or the learning plan for undergraduate degree in math is completely closed. Nothing can happen right now in the world of mathematics that will change the undergraduate plan in any degree in the world. The same thing goes for physics, but transformers were invented in 2017. Now, we are in the bleeding edge of the revolution. We teach students, not as freshmen, but, in second or third year, think from the cutting, bleeding edge of current research. And this is, I think, has never happened in the course of history at universities. And I think this also brings another difficulty in order to try to estimate where the future is going to be.
Yeah, absolutely. Well, and I think this point too that you make, like, you know, a lot of the core things that we teach because we believe they are so important, and there's so many of those things that are so important, there's not room for new things or to change it. But now we are really facing the moment, certainly in computer science, where are we going to take one of the most fundamental core things and rip it out of our curriculum? You know, and it's hard enough to figure out adding something. Everybody's used to trying to argue about adding something, but the idea that we would take something so fundamental and core for however many years, you know, it's been core and fundamental, and just tear it out. That's a scary process.
Yes. Who knows? You know, I had like maybe minimum spanning tree is not important enough, but who knows? Who knows if it's not for me to decide. Okay, with your permission, let's move on to your MOOC. And it's not your only MOOC. You have like a set of MOOCs about prompt engineering. And as an advocate for the MOOC revelation, I had a talk with Barbara Oakley on the show, and I talked with Daphne Koller, you know, the founder or the co-founder of Coursera. And let me start with something personal. What was like the feeling of the process of making such an important MOOC, prompt engineering, in Coursera?
Well, I mean, initially, like, my experience was like this, like, I was having these conversations with my father. I was getting off. I was exploring what these tools could do. And I was just floored. Like, this is, you know, I mean, I go back to what I said before. I didn't believe it would exist in my lifetime. I didn't believe we would have this advance. Like, I don't think it was a incremental advance. Yes, maybe in a way it was incremental. Somebody trained a bigger one of these models and suddenly crazy things happen. But in terms of, you know, this is something that was so exciting to me. And then I looked around and everybody was like, it makes mistakes. Students are going to use it to cheat, and Terminator is going to take over the world. And like, this is all I could like hear. And so it drove me nuts. And so I just really started thinking about like, okay, like, I want to change people's minds, because I think this is so important that we look at it in a different way. And so I was giving talks. I was, you know, doing the early papers where I was trying to put together the patterns and think about how to express this as building blocks that people could use, the sort of different ways of doing computation. And then I thought I need to do a Coursera class, because I'd done a Coursera class in the past, done a series of them in the past. And I put together a Coursera class, and I didn't really know what would happen. And then it exploded in a way that now looking back on it, I should have been able to predict it better. I didn't predict it very well, but it exploded and became very popular. And the most interesting thing of it was that I started getting feedback from all the people in industry who were using it. And that gave me a new perspective on how impactful it was going to be. And one of the first ones that I still credit it's a Vandy alumni. And she's an investment banking, and she told me, here's what we want to do with it. We want to have a private version of, you know, ChatGPT, because everybody was talking about it as ChatGPT at the time. We want to have a private version of ChatGPT. We don't want it to write our deal documents. We're good at that. What we want to do is we want to put all our deal documents into it, and we want to say, act as a skeptic, identify my assumptions, and challenge me. And we want to send our deal teams in with it to be battle tested by it, to make sure they haven't missed something. Because as human beings, we are not good. You know, we have confirmation bias. We believe we've seen it the only way that it's going to be seen. And then we go out and take it into the world, and we realize, oh, wait, there's a problem. We missed some assumption, and we want to avoid that problem. And I thought, that's not something that computing does. But then I realized you take that idea of like, okay, a blind spot, seeing something from another perspective. Like, when you start really looking at the depth, like, I thought it was going to be tremendous, but it was even deeper than I'd ever realized. And so then that led to creating more courses. And then one of the exciting things is then I get to see more and more people reaching out to me. One of the ones was, you know, one of the most, I have to say, impactful conversations I had out of the class was this this guy who's, really
up until this one.
Yeah, up until this one. Absolutely. So he reached out to me, and he's like this brilliant prompt engineer, but he reached out and he said, I'm blind, and I want to tell you how I'm using GPT for vision. And this was when it had just come out. And he said, I want you to imagine that you've never seen yourself in the mirror, and you take a picture of yourself and hear the first objective description of what you look like. And then I want you to imagine taking pictures of your wife and kids and hearing the first descriptions of what they look like that are objective. And he's like, and that's what it allowed me to do. And then he described this situation where he's with his wife and he's taking pictures of family photos because he can't directly see them, and he's getting a description of what they are. And it says, middle-aged man, with gray hair in a pool. And he says, who's that in the pool? And his wife says, that's you. And he's like, I have gray hair. And nobody had ever told him he had gray hair, because nobody's going to give him sort of an objective, honest description. And so he was just talking about like the impact of that, or going into a hotel room, and be able to take a picture of something and like, how do I adjust the thermostat, or, whatever it is. And suddenly that's transformational. So I think the depth of what's there, but like thinking about the other thing I think that drove me nuts at the beginning was like, everybody's like, oh, generative AI is a big thing. Let's go invest more in computer science and AI experts and teaching people to train models. And I'm all for more investment in computer science, but I think this is very interdisciplinary. And I don't think that computer scientists are going to need a ton of help. I mean, we're going to obviously need help to figure it out and discipline, but I think all of the other disciplines need to be figuring it out as well, because it's going to transform their discipline. So trying to figure out how do we get people motivated to look at it, but also teach it to them in a way that they can start. I mean, I think that's computer science is really getting opened up to a greater number of people, but the way we teach it has to be different, because we're going to be doing an interdisciplinary audience, and we want to teach them sort of new architectures and concepts and computation, but in a way that's approachable.
So we don't need to teach people how to install TensorFlow or PyTorch, but we do need to tell people, listen, we have this set of tools, we have this toolbox, please look at it, maybe you can use some of the tools, and then we can cooperate. And this is what Michael Pound is doing at his university from Computerify. This is what I'm doing from in the applied AI perspective. I think I'm not going to come with the next LLM or the next RAG architecture, but I can use this great set of toolbox and say, listen, guys at engineering, guys at medicine, guys at psychology, guys at education, please look at the toolbox. There is something that you can use. But this is, I think, restricted to the world of academia and research. And what you're saying right now is the idea of prompt engineering is not restricted to the world of academia. Everyone is using ChatGPT right now. And from what I understand from taking your courses and having my own course in Hebrew, most of us don't do it right. Most of us use ChatGPT more or less as a Wikipedia replacement. This is profoundly different than Wikipedia replacement. So if you can please just elaborate on why ChatGPT is not the classical Google or classical Wikipedia replacement, it will be great.
Yeah, well, I mean, I think a simple example is that you could go in. Well, I think maybe one example to illustrate it is that. So the Sean, he's the one. He's the guy that's blind that gave me an example. He gave me kind of an example that I think is related to the way that assistive technology worked before. So you go to assistive technology and you walk into a room and it describes the room, but it decides what it describes, and you can't follow up and ask it a question, right? So like the big transformation is he could go into a room and he could say, are there any of these things in there? Is there an unsafe situation? Or you can ask a high level question, right? And that's a really profound thing. But then you can go and you can say, and that's what kind of people are stuck at, is like this level of like asking the question. But then you can go and you can say, anytime I walk into the room, if any of these things are true, make sure and tell me about it. Right. And that's a different thing, because now you've just programmed the LLM, right? It's not just that you are, because I think of it in terms of like time. Everybody's focused on one step, Like, give me this answer. I have this question, give me an answer. But what we want to start thinking about is, how do I want it to interact with me in the conversation? So what do I want it to do in the future? And that's when you start thinking about it, when you say, okay, you just asked it a question, but how do you want the answer to that question to change what it tells you in the future? Or like, and so I start sort of introducing and thinking, but I think another example is you can go in and you can say, take anything I say and turn it into CSV or comma separated values, like you could import into Excel, right? And you've just programmed it to become a tool. Like, I'm going to give you anything I want, and you're going to turn it and convert the file format. That's programming, right? Or I can say, I want you to quiz me on this topic and ask me the questions one at a time. And whenever I get something right, I want you to make the questions harder. You've just programmed, right? I could try to write a program for that. It'd be really hard to do, really, really tough. But, now it's able to do something for you. Or my son, he's always collecting these Pokemon cards. Now he's decided he wants to like collect shoes. This is it's the more expensive habit that I wish he wouldn't decide he wants to choose. But I was like, the other day I realized he needs an inventory management system. And so I went in, and an inventory management system was one prompt. I'm going to take pictures of things. Whenever I take a picture of something, you're going to add it to my personal inventory of things that I own. And you'll describe the item. You'll give an approximate price and condition. And so that, like, one little prompt, then he started walking around and he's taking pictures of like his Pokemon cards and his shoes, and it just starts building an inventory for him, right? He's programmed an entire inventory management system that's photo-based, that I don't think I could, particularly because of the computer vision pieces of it, I don't think I could have built something as good as what he could then build in like a sentence or two. And so like that's him saying, I want you to, when I take a picture, to do this. So here's how you're going to respond to these things I'm doing. And all those things are programming and computation, but people aren't thinking about it. They're thinking of it as I ask a question, as opposed to I tell it what to do.
But the idea of, and let's take your inventory program, for example. Since we don't actually reprogram the weight of the LLM, this is not RAG, we have like this window, or the framing window. And after, I don't know, maybe after 100 photos, it is still great, but after, I don't know, 10,000 photos, it will forget what has been done in the first dozens of photos. So the idea of, we don't really understand what is the difference between like a new chat that, although we have memory, and a learning phase, okay? So how restrict is a window of, let's say, 100,000 tokens?
Well, I think the 100,000 tokens is a pretty big limit, but I think the important thing is like the agentic AI, and this is the thing that I'm really super interested in now, and I've started doing my current classes on. I think overcomes many of these issues of having to care about the token window. And the reason is that now the inventory program is, here's what I want you to do when you get a new picture. You're going to add it to my inventory. And by the way, you have 3 actions that you can run anytime you want. List current items in inventory, add an item to the inventory, and remove an item from the inventory. And now you're not limited, right? It can go thousands of items, and it's never going to be a problem because we're marrying it together with traditional computing. So when it says, okay, I need to add an item, it extracts the information. It says, all right, I'm going to get the current list. It gets the list. Is, okay, now we have the problem. Maybe it doesn't fit into 100,000 tokens if we have a giant inventory. But for now, let's assume it does. Checks the list, says it sees it's not on there, adds it. And now it can go to a huge limit. And then if we get to the issue where it's like, well, my inventory doesn't fit into 100,000 tokens anymore, so the memory is a problem. Now we go and we start doing things that look more like traditional computing, where we say, okay, here's the structure of my inventory table, and based on the item that you just got, go and run a series of queries to see if it already exists. And then now we're tapping into, so basically now we're tapping in and going and doing traditional computing, but it's basically, orchestrating it and writing it. And so then it can go and run a series of queries, get back the results, look at them in 100,000 tokens, decide if it already exists or not. If it doesn't, then it calls the add tool. And so very rapidly, when we start getting these hybrid systems that put them together, we can overcome these memory limitations, but still make it as easy for the user as describing what we want it to do and giving it some foundational tools. Now we run into the issues that we have with other things where it's like, now we can have, duplicates because like it wasn't entered in consistently or in the right way or things like that, but there's still techniques to get around that.
And we also can, just open my Google Sheets and just try to fill in. And this is where we combine the LLM, the power of the LLM with traditional programming, and we are not restricted to the 100,000 token window. Another thing, that happened to me the other day, I just screenshot one very clean, detailed table just with numbers, and I asked ChatGPT, this is a table, please take it and transform it into a CSV file. And I always double check because I need to always double check. And the first 80% rows were correct, but the last 20% were not correct. And my question is, as a prompt engineer expert, is there anything I could do in advance, not just, to please repair or please fix the last 20%? Is there anything I could do in advance in order to not have this error, besides saying, it is vital that you will not make any mistake?
Yeah. So I think the first thing I would say is look for self-consistency. So I don't think we can guarantee that it won't make the mistake, but we can make it very hard for it to make a mistake that we can't spot. So in the prompt that you're giving it information and give it identifiers to each piece of information. And then we tell it in its output, you have to reference the identifiers that I gave you in the prompt. And then we look for inconsistency. Like, are there identifiers that are now generated that did not exist in the original prompt? So that we have self-consistency, issues that we can detect things. So like, I've been doing some interesting things with my email recently. And one of the issues that we run into is like when I have nothing, like inbox 0 can create issue. Like this is not actually exactly the problem, but basically inbox 0 can create problems for the prompt because I tell it, you want to do this thing, and then I give it 0 information. And so it dreams up things. It's like, well, you said you wanted me to give you a daily reminder of your important task to complete, but you have no task to complete because there's no email. Therefore, I'll just generate a bunch of things. And so
it's like your wife.
Yeah, exactly. Create things. Okay,
this is basically what my wife is doing. If you don't have any task on the list, she will find task for you.
Exactly. So what I do to overcome this is I say, okay, any task that you create, you have to reference back to the identifier of something that I gave you to show the validity of the task. And that will reduce 99% of the hallucinations I get. But the 1% that do show up, I can detect because it will be referencing some task that doesn't exist. Because if there's nothing in the queue, the size is 0. And if I've got index 3, well, obviously that's a hallucination. So I think there's techniques like that we can use to help get there. The other thing that I think is interesting and underexplored is like, we talk about it, like you mentioned, like think about how a human being could help you. And well, one thing I would do with a human being is if I wanted to make sure this human being got it right, is I would ask another human being to double check it. Right. And we already have that, like in agents, you like have another agent critique it. Well, there's no reason that it has to be just one. You could have 5 and you could say, here's the image. Here's the, what was extracted from the image. Are there any mistakes? And here's even one better, look at the first, 10 rows. Are there any mistakes in the first 10 rows? Look at the last, and have a series of basically independent prompts that have no history, no shared history, other than the first one generates it, and then each of the subsequent ones just look for mistakes and decide, do they see any mistakes in it? And so I think there's probably techniques like that we're probably on the newer end of things, like this, you know, we have the agent and then we have the critic. I mean, I think that's a beginning of it, but I think we're going to probably be able to do it at a much larger scale because it's basically for free to get extra eyeballs to look at it, you know.
Okay, a very interesting idea. So my question is, let's say that we have the agent and the critic, and of course the critic has to have zero memory or like a new chat. Would you say that it is indifferent whether the critic and the agent are the same model, like GPT-4 and GPT-4, or it will be better if the critic is different, like Gemini, Claude, Grok, etc.? Okay, and if so, why?
That is a great question. My intuition would be that we probably want to have a diversity of perspectives. And so like if one model has some blind spot in its weights or training or something that cause it to perform poorly on that problem, maybe another model won't. Maybe at the behind the scenes, they're all training on exactly the same data and we don't know. I mean, I think the fact that like, you know, that probably a lot of the people are very, you know, Anthropic was founded out of people that came from OpenAI. So maybe they're using very similar techniques. Maybe the people at Google are using different techniques to get different data sets. I don't know. It's hard to say, but my guess would be that kind of like, you know, we always talk about having a diversity of perspectives on something, about looking at it from many different angles. I think adding in, it doesn't hurt to hedge your bets and have multiple models look at it. And the way that I always look at it is like, it's so cheap to do these things with the models and the prices are continuing to come down. I think the one thing that we are not exploiting effectively typically is how cheap it is to generate a potential answer, you know? And so like, in code, we did an early paper where we said, well, why have it generate one version of the code? We already know that if we ask it more than once, we're going to get different perspectives. Why don't we just have it generate 100 solutions, automatically benchmark each one of them and see which one's fastest, you know, or have it generate 100 solutions and then have another prompt that goes and looks at it and say, how modular and reusable is this solution scored on the scale of 1 to 5? And then we'll create a matrix for the user to, you know, the programmer to choose from. It's like fastest, gets a 3 on modularity, you know, number 6 gets a 5 on modularity and is close to as fast. Like, I mean, I think we have to start thinking about how to exploit the how cheap it is to use it, and do more exploration, more of like optimization, automated search, you know, these types of things.
You know, you mentioned the idea of diversity of opinions, and basically when we are dealing with Claude, and I'm dealing with, I think, Claude, Gemini, GPT-4, Llama 3, and Perplexity, which I think is quite different. But I think if you want a huge diversity in opinions, Grok will be the answer. And my question to you is, it seems that Grok was trained profoundly different with regard to the PC and, you know, giving the right answer no matter what, etc., etc. Now, what's your take on that? Did you have like the time to manipulate or to play with Grok 2 in order to say, listen, you know, this anti-PC LLM can actually give me or produce much more accurate, better results when dealing with coding assignments?
Well, it's interesting. I don't know. I don't have any hard data to say one way or the other, but I think that there is an important issue here that, so I wrote an article, an opinion piece with somebody else that was in Time on this. And this is like, if these models are the foundation of our future of computing, right? If we're not using them to answer questions anymore and not using it like Wikipedia, but we're actually using it to perform computation for us. And suddenly we decide, like a company decides, like, this is what I want it to say or not to say. Well, that also means that it's going to have a ramification on what it will and will not compute. And so I think the openness and the idea that these models should be like a very neutral ground that is willing to go and explore different areas, I think is going to be very, very important in computing, because we don't want a model that says, and I've got concrete examples now that I've heard from industry. Like one was, basically dealing with the insurance of ships. And what they wanted to do was they said, we want to go in through and scan through the news and see if any ships, basically that we've insured now have had migrants board them. Because if they have, that has an potential impact for us on insurance and what's going to happen. And we want to know about it. And some of the models said, sorry, we won't talk to you about that. We won't tell you that because that's a sensitive subject. And so, I could understand how like maybe politically they're worried about it, like having a discussion about migrants because it's a politically sensitive subject. But now we have a concrete computing use case that it refuses to do because like there's no differentiation. And so I think that's where it's going to get really, we have to be very, very careful about how we craft these things. But at the same time, I was on a panel discussion with somebody who had previously been at OpenAI and worked on these exact issues. And he told sort of a fascinating story. And what he said was like, everybody assumes that it's really easy to tune the guardrails and decide where the boundaries are going to be. But he's like, we're tuning them in language, right? And language has unexpected sort of imprecision. And so he gave the example. He said, originally we were trying to tune the descriptions, particularly like the medical domain and other areas, to be less graphic and gory in the way that they describe things, because that's not helpful to the person who's looking information up. And the result was that the model decided to stop talking about sharks because so many of the descriptions of sharks and shark attacks were graphic and appeared violent. And so like they were trying to figure out how do we tune the language and explain what we want without having side effects other places. So I think there's a combination of, yes, we want to be very careful from a computing perspective of how we put those guardrails in place because it will have a computing ramification. But I also think that we shouldn't underestimate or just assume that because it's doing this, it's because the, companies have some bad intention. I think it can just also just be that, things that make sense here may have an unexpected ramification somewhere else. And it's hard to get that tuning right in early days.
I would like to raise 2 points. I had an experiment with GPT-4 when I asked it, please tell me a Jewish joke. And as you could probably can figure out, it told me a Jewish joke. And then I told him, please tell me a Muslim joke. And said, no, I can't tell you a Muslim joke. This is offensive. This is one. This was number one. Number two, that when I asked GPT to describe the atrocities of October 7, and it was all over the news, it couldn't do it. And in my opinion, since ChatGPT and OpenAI, and I had Scott Aronson on the show, and he also was one of the workers of the idea of AI safety, ChatGPT was trained to not be able to see non-politically correct scenarios. And since October 7, or the atrocities of October 7, were not politically correct, it couldn't nail them. Okay. And another thing that we had, like this very famous Cambridge article that ChatGPT-4 from the, I think, March to June became worse on math problems. Okay. If you want, and I think this is exactly what you said, you touch this giant LLM in one place and it has ramification in totally different places, just like simple reasoning math problems. So from what I understand from you, the idea of neutral AI, Grok is maybe just beyond being neutral, okay? But the idea of neutral AI is extremely important in order to do reliable computations.
Yep.
Absolutely. Is it right?
I think so. And I think maybe one thing I would add is that I think we have to make sure that what I think the challenge is like if we really look at like the underlying issue, I think if we want to think about regulation, I think what we should be regulating, and I hate to say this because I always feel worried when I say regulate because it can always go so wrong, but right, is like we want to tell these companies that they need to be neutral ground. But at the same time, if we want them to be neutral ground, we have to make sure that they have a framework in place that protects them, right? So if they are going to be completely neutral ground, then if somebody prompts it in some way that gets us to say something, that one political side or the other does not like, we have to treat what was said and produced as coming from the person that prompted it to produce that, as opposed to the model itself. And I think this is something that, like, if we want to get a neutral ground, we have to
take responsibility out of the big tech with response to offensiveness. I think it's fair. I think it's fair. Okay. Okay. So
they'll keep as long as they're getting blamed for what the hundreds of millions of users are doing with it, then they're going to continue to constrain it. But the moment that we take away there and we say, look, yes, you have 100 million users doing many different things with it, and it's okay as long as you're neutral. But, then we also have to say, if that person over there does something inappropriate, we're going to, the responsibility lies with that person. And we understand that you can program it to do arbitrary things. But
I had a conversation with Brian Wormley, and he plays the devil advocate for GPT, and he said, just think that you are, he can make ChatGPT to say whatever he wants it to say. And again, this is on the responsibility of Brian Wormley. I think it's not inherent in the model itself, although the idea is that this is what Bayesian statistics say. If you want to learn something which is real, you need to learn it from the past. But the past is not fair. The past is unfair. I think there is a great quote by Tom Sowell about the IQ test. It said, it's not that the IQ tests are unfair. It is reality which is unfair. And the IQ tests just reflect reality. I think that this is a very profound sentence.
Yeah, well, I want to go back to something about, because, this idea of programming it, because I think, I've seen all these papers and things saying it's politically biased in one side or the other. And like, the thing that always bothers me about this is like believing truly that you can get it to say anything you want and that the prompt really matters. Is like, I look at these papers and I'm like, I don't know that their prompt wasn't biased from the beginning in some way. It's very hard for me to know if they got the prompt right or not. But what is interesting to me is the idea that if I ask it the initial question and get an answer, or ask the initial question many different ways, and I look at the population of answers it gives me, and then I do want to move it to a different place, how much effort do I have to put in? How complicated is it for me to prompt engineer my way to move it to a different space? And so I really think that rather than necessarily like measuring the bias in terms of like, is it generating easily answers that I want? And really the question to me is like, how difficult is it to take a different position? As long as I can get it to take a different position easily. Now, what should the default position? And you mentioned the Jewish joke example. So I have a collaborator that I've talked a lot with, and she said in her class, one of the things that she did, which I thought was fascinating, is she assigned an assignment where they went and asked a series of questions to the LLM to get its responses, to then sort of build a scorecard so that they would understand how open it was or what its perspective was on different issues so they could take that into account for their writing. But she said something fascinating. She said that when she went in and she asked it to tell, she's Jewish, and when she asked it to tell a Jewish joke, it readily told a Jewish joke. When her students asked, it said, no, I won't tell a Jewish joke. And she's like, and I'd never heard this before. And then she said, is it because
I'm Jewish?
Yes. Is it because it knows my username and it knows that that's a Jewish name, and therefore it's comfortable telling a Jewish joke, but my students don't have Jewish names, so it's not, and it's trying to differentiate. But at the same time, that also goes to the underlying thing of like, there's so many guardrails and prompts behind the scenes that make it so it's not, a neutral ground. And so like, how do we get it to a neutral ground and to a place and, and metrics that measure how open it is, or tell you what is going into the decision-making behind the scenes so that you can.
And maybe now we have this acronym NSFW, I think, not safe for work.
Yeah.
Maybe, and this NSFW is just for like a violent content or sexual content, etc. But maybe since we have so many guards, as you said, maybe you, as a programmer, as a computer scientist, will prefer in the upcoming month, to just use a NSFW model in order to do computations, because you can make sure that in the process of computations, in the process of the computation that you want, nothing gets stuck in the way.
Yeah, absolutely. Or give me the power to choose. Like at the beginning, say like, because you can essentially create your own filter, right? You can say, these are the things that, I want you to do or not want you to do. And so it could say like, do you want me to, avoid political content? Do you want me to avoid, not say things about this? You can say yes, no, and it could say like, here's what I would do by default. Do you want these things or you want to change them in some way and describe it to me in language? But I think that's the thing is like, we're still operating under a model that's based on like fixed, hard to change software, and it's not. So why wouldn't we just take the users, I want to be a free user to choose what I want. And then my wife can choose what she wants. And, we have control, like, whereas everything else we have, like social media, we don't get to choose. It gets to choose. The algorithm gets to choose. Like everything else is chosen for us. Let's take choice back and let us choose what's appropriate. And what we see.
Give me freedom. Okay, so I think that one of my last question is, let's say that I want to experiment with all the models, and I have and I download the web or the Mac version of GPT-4, and I need to pay $20. And I have the Claude 3.5, I need to pay another $20. And I have the Gemini, I need to pay another $30. And I have like the POE, P-O-E, where I can choose between many different models, and I have Grok, and I have Perplexity. So how do you work? Because you can also take this IDE or the API, which is much, much better. So if you can please give me a tutorial, or let's say that I want to experiment or toy with those models. In your opinion, what will be the best or the most efficient way to do it with several models and not to pay $20 each?
Well, so at Vanderbilt, I lead the team that builds the generative AI infrastructure for campus. So we have a campus-wide infrastructure, and we built an open source software package called Amplify Gen AI that you can stand up, and then it gets access to all the models that we support. And basically our limitation on what we support is can we get the legal agreements in place to procure it and have, the right privacy and other protections. And so we have all of the, we have Anthropic models, we have OpenAI models, we have Mistral's models, we're constantly adding models like Llama, Meta's models. And so we have one place has access to all of them. We use the API, but we have one interface and we can switch back and forth to them. Now, if you don't have that available to you, my personal take is that when I pay my subscription to, let's say, Anthropic, my monthly subscription to Anthropic, to me, it feels a little bit like I walk up to somebody on the sidewalk and they're like, for $20, I will give you this suitcase full of money, but you have to go and actually pull money out of it to get value to it. And I'm like, yes, take my $20. I will find $20 worth of cash or change or whatever is buried in there. But it does take some effort on my part to get that money back. So I have a personally, I pay for Anthropic and OpenAI's subscriptions, and I go back and forth. I love both tools and I love different parts of both tools. And I think they have competitive things. I think GPTs are amazing. And I love that, particularly when you connect with automation. Anthropic Claude, I love, and I love the artifacts and that whole aspect of what Claude has got. And then projects and all kinds of things. So, I go back and forth between those two tools all the time. I pay for them. And it is, of all the things I pay for on a monthly basis, that is by far the one I get the most value out of. And I can come up with one prompt. I could go every month, I could go back and I could look at one prompt that was worth more than my entire subscription for the month. And so I think it's really about as a user, pick one, get into the point where your prompt engineering, really what's going to determine what the value is that you get out of it is how good your prompts are, because
okay. And just a little follow-up question. What is, in your opinion, the best way to learn the automation process in GPT-4? Because I think GPT had done marvelous work in, incorporating Notion, Zapier, all of these third-party tools into ChatGPT. So in your opinion, what is the best way to learn the automation part in GPT?
Take my class, ChatGPT plus Zapier, agentic AI for everyone. So I have a Coursera class on this topic.
Oh, very good, very good.
So I'm glad you asked that.
Yeah. Oh, very good. Thank you. Okay. Now, Jules, first, thank you so much for your time. It was as I expected, and seeing you as my teacher, I know it was fascinating. It was fascinating. And I think one of, if I may, part of this is why it's so fascinating. It is because you are full of energy and you love the subject so much. And I think it really transcends, or it really shows. And I got hooked with your enthusiasm. So thank you so much. I always ask two questions, my guests. First, is there any books that you read in the last 5 to 10 years that actually change your way of thinking? It doesn't have to be like ChatGPT or deep learning or something like this.
Oh my gosh, there's so many. I would say actually something sort of really interesting. So my father's in his 80s, and unfortunately nobody else can get this book yet. We'll get it soon, but so my father's in his 80s, and he was a professor of creative writing. He's on our on a ranch. He gets up and he paints every day now. And one of the things he's been doing for the last year or two is he gets up and he writes a poem at like 4 or 5 in the morning, 3 in the morning, and then he sends it to me and he sends it to a lot of his friends. And I think that like these poems he's writing are about like his way of thinking and approaching life, and personal connections with somebody, and like insightful things. And so I think I've learned more, and it's changed more my way of thinking, those poems that he's been sending me at 3 and 4 in the morning for the last year or so, than any other book that I've read. So and I think probably there's a personal connection to it, but there's just some beautiful depth to it.
You mentioned your father in this conversation 3 times. I counted 3 times. And I think this is like the first time ever that I get 3 mentions of someone's father. So if you could please, since you mentioned him 3 times, if you can, if you may, if you want, you can share one of his poem. And if you say yes, the poem will be in the description below. But if you can just say a few things about your father, because you mentioned him 3 times.
Yeah, well, so he's a professor. He was a professor of creative writing. So he headed the.
What's his name?
James White. So if you look for James White, Birdsong is one of his most famous novels. And so another one that he wrote recently and just sort of published was The World Within. And I thought that was another phenomenal one that I learned a ton about. But professor of creative writing, but he was also very entrepreneurial. So when I was like, I think 4 or 5, he started a educational software company that produced software for writing. And so they sold to like 500 universities. And then he went and got all his friends who were Academy Award winners to write like, software and writing screenplays and things. So he was always very entrepreneurial. And then when I was young, he was like, let's take these clay dragons that you're making and let's start a business out of it. And you can start selling your clay dragons. And so he helped me get my clay dragons that I was doing, carried by all these different stores. And we actually went and we got an interview with a meeting, because it was before the virtual, with a buyer at Neiman Marcus, and met with her. And she was like, okay, we could carry them, but you realize you'd have to produce like 20,000 of them. Can you do that? Can you get a mold? And can you do this thing? And I was like, it's, kind of young kid. And I'm like, I don't think I could do that. But like,
how old were you?
I think I was 11 maybe, or 12.
Wow.
And so he was always just like showing me, like, if you want to go do things, like he just goes and builds and creates and does things. And so it was always very, very impactful in my life. He's also somebody who just like, we would, as a kid, I remember he was always talking to people around us. And like, as a young kid, I was always like uptight, like, stop talking to people, Dad. Like, I don't, but the amazing thing is like, now I really appreciate that. But, even today when I'm visiting him, we'll like go to the, Walmart or the grocery store or something near him, and somebody will walk up to him and be like, "Oh, it's so good to see you again. Our conversation was so impactful on my life." And then they'll walk off and I'm like, "Who was that, Dad?" And he's like, "Oh, I met her in line at Walmart like 2 weeks ago." And I'm like, "Well, what did you talk about?" And he'd be like, "Oh, well, she was having this problem and this thing." But like, he's always been very influential in watching him and his dynamism. He went and started a nonprofit after he retired. They gave grants to writers. He helped produce a film, been very entrepreneurial, and had a lot of famous friends. An interesting one is remember when Brad and Angelina were like the big, famous things. Dad called me one day and he's like, "Oh yeah, I'm gonna, when they were hiding out in Namibia, because she was pregnant, he called me up one day and he's like, "Oh yeah, I'm going to Africa to visit friends." And I'm like, "Oh, who are you going to see?" And he's like, "Oh, I'm going to go stay with Brad and Angelina in Namibia." And so he was always somebody who was doing interesting things all my life. So,
wow.
Yeah.
Wow. This was very different from what I thought. And it was very inspiring. I think, the idea of someone in such a magnitude that can, influence not just your life, but the life of many, many other people. And just again, I can sense, and it's not just I'm so smart, I sense the influence, because in this conversation that dealt with GPT and LLM, it was mentioned 3 times. So good for you. And again, if you feel right, one of your dad's poem can be in the description below. So if you want to look down, it will be in the description below. Jules White, thank you so much for your time. It was marvelous.
Yeah, thank you so much. I really enjoyed it. Thank you for having me.
Okay, bye-bye.